Okay, can you all see the screen, all of you? Is it being shared, students? Okay, Cecil Online, Delicia Island, Malavika, and 1, 2, 3, 4, 5, 6. Okay. So we'll continue circles, yesterday's circles concept. Fine. I explained about the chord, segment, sector, or you're thorough with all those concepts, students. Segment, sector, and all those things. Tell me the two theorems. How did I teach you all? What are the theorem? What's the first theorem I told you all? First theorem, center is equal to what? Circumference. So the arc should be same. If I take a arc A and arc B, students, arc B, this is the arc. If I take angle center here like this, okay, and the same one, AOB is the center. Angle formed in the center is angle AOB. Write it as angle AOB is equal to twice. Angle formed on the circumference. Look, the starting point is A. I'm going to touch here. I'm going to touch this corner like this. Tell me what's the angle formed? ACB. Can you see angle ACB given? All of you respond, students. ACB is the other angle, same arc. Or I can take A like this, CB. This is the second one. Okay, angle ACB. Just observe the starting point and ending point, these two. Fine. Next. What about second theorem, student? What is second theorem? How did I tell you all to remember? Circumference is equal to circumference. Angle formed on the same circumference. Angle formed on the same arc. Look here. And this one, the center, whenever it forms in the center, arc plus what is it? Chord or radius? Is it arc? Chord or radius, right? So what is it? Arc plus radius is sector. Sector or segment? Sector. Sector is equals to twice. ACB is what, students? ACB was segment, right? Segment. Now when it comes to circumference, both segment. For circumference we use segment. Segment is equals to segment. So what is segment? An arc which touches the circumference. That is segment. See, same arc AB. I'll touch the line here like this. ACB, 50 degrees. If this is 50, what about ADB? Same arc. On same arc, same segment. ACB is equal to which one, students? ADB. 50 degree is equal to 50 degrees. Clear? Next, in a circle. This is what we did. Till here we did yesterday. Okay, it's an easy concept. Next, let me take a circle. There are 4 concepts in this. You have to remember 4 concepts. In this circle, I'll take arc A and B. Arc is just a part of the circumference A and B. And if I join a point here, this is known as angle subtended by this arc. Angle subtended. This value, if I take it as 70 degrees, let me take it as 70. Okay. What's the value of a total circle, students? One full circle is how many degrees? Remember this concept, the remaining of this. Yes, can you see the blue one, the remaining part outside? If I take this circle, this particular part. See, the black line is covering only till 70 degrees. What will be the remaining value? 360 minus 70, or let me 60 degrees here. 360 minus 7, 360 is how much? 300. This angle, the inner one we call normal angle AOB. Normal angle AOB because it is towards the arc, students. It is formed inside the arc. Normal angle AOB is equals to 60 degrees. The other one, have you heard of this reflex angle? If not, make a note. Reflex AOB. We call reflex AOB. The formula is 360 minus whatever angle. 360 minus angle AOB. This is the formula. Make a note. The remaining part we call reflex angle. Reflex. So entire both put together 360 degrees. Completed? All of you understood what is reflex angle? Now we'll put all three together. So first we did first theorem, second theorem was done, students. You can remember in any order. Third one is reflex angle. Based on that, we'll solve a question now. I'll take P, I'll take Q. This is the arc. Oh. Remember this, if you take a triangle, students, you take a triangle or any diagram like this. The angle formed inside, we call it, this is known as angle. Okay, angles or angle. The point where two lines meet, we call vertex. Remember this. We call vertex. So a triangle has how many vertices? A triangle has three vertices. Outside is vertex, inside is what you call angle. Okay, a triangle has three vertex and three angles. Now, this is angle given. What do you call this angle? What's the starting point? You can name it in three ways. You can just write angle O, or you can start from P, starting point POQ, or you can start even from Q, QOP. Fine. But we always take according to alphabetical order. P is first, students. POQ. We take angle POQ. Fine. Now I'll give you all one question. This. Find angle PRQ. First thing, what kind of diagram is this? This entire thing. All of you will respond. What kind of diagram? Circles? No. Entire diagram. I'm just talking. In general, it's a circle. So in circle, what are the concepts we have studied so far? Center is equal to twice the circumference, right? Angle formed on the circumference are equal. Two theorem. And what's the other one I told you? Reflex angle? Yes, reflex. In this, what I've asked you all to find, students? PQR. PQR is where? Formed in the center or circumference? Where is PQ? You don't know which is R? Amy, you can't figure out R? Is it center? So which angle we need to find, students? Which angle we need to find here? I want even others to answer. Aarti, what is Aarti doing? Malavika, Anya, Aileen, Delicia. What are students doing? No, you forget about that. You forget about that. Whatever I ask, you tell, Aarti. Okay. Whatever I'm asking, you'll have to tell students. You try to do it directly, one or two questions you'll solve. After that, if I give some tough questions, definitely you'll forget. You won't even know how to approach the question. First, tell me what is PQR? Where is it formed? Center or circumference? It's in a circumference. If you want to find circumference, which angle you have to find? Center angle should be given, right? One, which is the center angle here, students? Which is center angle? Which is the angle formed in the center? POQ. Is it given? Is POQ given? No. If you want to find PRQ, what's the formula we use? Center is equal to twice circumference. Use that theorem. What is center angle form? Angle POQ is equal to 2 times angle PRQ. If you find the value of POQ and if you substitute, you'll get PRQ, right? So first thing, if you want to find POQ, students, POQ is not given. Take this entire circle. Take this entire circle. What did I tell you? This 250 is what? Is it normal POQ or reflex POQ? Reflex. So first write that. Reflex angle POQ is equal to, what's the formula I told you all? Minus angle, not angle A. What is it? POQ. PQR is outside, Bhargavi. What are you answering? Hmm. Is PRQ in the center or outside? It's in the circumference, right? So take down the formula, students. For reflex angle, the formula is normal angle POQ plus reflex angle POQ should be equal to 360 degrees. This is the formula. Make a note. While teaching, I interchanged it. This is the formula you have to remember. Normal angle POQ plus reflex POQ should always be equal to 360. Okay. So this is the angle formed in the center. Which angle is given here? POQ or reflex POQ? Which one is given? Reflex angle POQ, right? What is reflex angle POQ? 250. So angle POQ is equal to 360 minus 250. First subtract this. Once you subtract, you will get POQ. Substitute here. Find the value of PRQ, all of you. Good, 55. So this is a tough. Yeah, tell me. 360 minus 250 is how much? One more thing, it's a tough chapter, students. Those who really want to study, who study well, or really those who concentrating, only they can solve this. Okay, and if you feel it tough, if you are playful, just ignore, just attend, just ignore this chapter. You can concentrate other chapters. If you really want to score good marks, concentrate and complete it. Angle POQ is how much? 360 minus 250 is 110. Substitute this 110 top is equal to 2 into PRQ. If you want to find PRQ, divide it by 2. Bring this 2 down and divide, you will get PRQ. This is how you solve the question. So you can write this below this, students. You can write it below. So if you have understood the concept, find POQ first. Substitute the angle for PRQ is equals to 55 degrees. There are two more concepts, semicircle concept and cyclic quadrilateral concept. Is it clear? Did you understand? All of you all done? Next, same PQ students. In same PQ, if I give another angle like this, PSR. Where is this PSR touching? Center or circumference? PSR. Where? Circumference. Then if you want to find this, which concept can we use? Both angles are on circumference, right? So both are equal. What are the two angles? Angle PRQ should be equal to angle PSQ. If PRS is 55, how much is angle PSQ? 55 degrees. This is the concept of first theorem, second theorem, and reflex angle. Shall we try the next one? Okay, theorem 1, by definition, what is the theorem 1? What is given in your textbook? Can someone tell me theorem 1, students? Any one of you have textbook with you all? Angles lying. Okay, angles lying. What's the spelling of lying? Lying or li lie? Correct, right? Angles lying on the same segment, students. Same segments are equal. So which one is this according to the one which I taught? Which is this, first or second? Same segment. What do you mean by same segment? Circumference is equal to circumference. Is this clear? Did you understand? So according to your textbook, they have given this is theorem 1. You can do it in any order, student. Circumference is equal to circumference concept. Tell me theorem 2. Angles of the same. Read out theorem 2. RT. Angle formed in the center is twice the circumference. Angle formed on the same arc. Okay. What is circumference? So what are the keywords there? Center, doubles, right? Okay, I'll write. You just ignore that, students. I'll write angle subtended by an arc at the center. Take down this definition. Definition usually they don't ask. Angle subtended by an arc at the center is double the angle subtended by same arc. The angle subtended by same arc on any part of circumference. On any part, I'll just give that any on circumference. This is theorem 2. So by definition, see, it is not that clear. I'll explain both together once again. Theorem 1 or theorem 2, don't remember it like theorem 1, theorem 2, student. Just remember center and center. Circumference. According to the first theorem, what have they told? Angle lying on the same segment. What do you mean by segment? Segment is made up of arc and what? Chord or arc and chord, right? Okay, let me take an arc AB and let me take a chord. Chord always touches the circumference, students. ACB. This is one angle and another angle like this. Angles lying on the same segment. The meaning of segment is on the same arc and different chord D. This is what they meant. So I just skipped all this. Remember, circumference is equal to circumference. On the same arc, circumference ACD is equal to ADB. This is how I explain circumference and circumference. Next, theorem 2. Angle subtended by an arc on the center. Remove everything. I just took the keyword. Center is double. What do you mean by double? Twice, right? Center. Center is meaning is equal to, double meaning is twice. Angle formed on which one? Circumference. This is what I. So keywords are important here. Center is equal to twice. Subtended meaning is nothing but the angle formed. Look here. Is double the angle, not subtended, formed. Angle formed by same arc on the circumference. Or subtended is also fine. Let me tell you what is meant by subtended. I'll take PQ. This RPQ, subtended meaning is from one point to another point if I touch the center. This is known as subtending. So the angle formed in the center according to this equation is 2 times. That is what I've written. Center is 2 times circumference. It can be anywhere. See, it can be even like this. You'll get questions even like this. Concentrate here. See, this is center. P, Q, R. Okay. From here, if I join the students, this is on the circumference. If the angle formed is 100 here, on the circumference it is half. What is half of 100? Half is 50 degrees. If the angle formed, if PRQ is 100, what about the reflex angle? What will be the value of reflex angle? 360 minus 100 is 260 degree. This is the concept. So look, don't get confused. Reflex angle is different. This POQ is not 130 degree, students. It is not 130. So for now, just ignore this. Just ignore. When we solve few sums, I'll explain. Only then you'll understand. Angle formed in the center is twice the angle formed on the circle. Okay, even by definition I gave that. Then we learned reflex angle is done. Next one. Theorem 3. Angle formed in a semicircle. Angle formed in a semicircle is 90 degrees. Make a note of this. Angle formed in a semicircle is 90 degree. What do you mean by semicircle, students? What is semicircle? All of you will respond. This is a full circle. Semi meaning is half, right? Half. So which line? Which line divides a circle into two parts? What is this middle line we call, which runs through the center? Diameter. Our diameter will split the entire circle into how many parts? Two semicircles. First one and semicircle 2. What is given here? Angle formed in semicircle is 90. The meaning of that is a triangle is formed, students. A triangle. Let me take this semicircle like this. So from this point A and B, I'm going to draw an angle like this. Circumference is it's going to touch. What is the angle formed here? According to definition, this value will be 90 degrees. Make a note. This is a fixed concept. Like this. Even this one, if I write like this. Isn't it forming through the semicircle line, diameter line? All of you respond. Yes. But if I take a chord, students, if I take a chord is not a diameter. If I connect this, this is not 90 degree. Look, this is not 90. Only through the diameter, this is 90 degrees. Make a note. Write this. If you take a chord, that is not 90. You should take a diameter. Through diameter, if you touch any of the circumference, if a triangle is formed, it is 90 degrees. Yes. In your textbook, it's given as theorem 4. Okay, take it as theorem. No, the previous one was not theorem, Bhargavi. That is just a reflex angle concept. That's not theorem. Reflex angle. This is a theorem. All of you have completed. So, what are the concepts you have studied? Theorem 1, Theorem 2. Next, reflex angle and angle formed in the semicircle is 90 degrees. Do you all have any doubts, students? Any doubts? All four put together will solve one question. All four put together. A line passes through the center. What do you call this line as? Anything passes through the center. Yeah, we can call diameter or even chord. Chord is fine, but specifically diameter. This is the arc. Okay, so diameter line is different, arc is different. This is arc, students. Arc is given. Fine. Let me explain. Theorem 3 was done. 4. Then we'll start solving question. Take down theorem 4. Theorem 4 is nothing but cyclic quadrilateral. No, it's not. So only 3 theorems, okay? Theorems. The next one, next part concept is cyclic quadrilateral. Put that in a cyclic quadrilateral. Did ma'am teach cyclic quadrilateral? No? Okay. See, what is cyclic quadrilateral, students? If you take a circle, what do you mean by quadrilateral? Do you all know quadrilateral? Yeah, what is quadrilateral? Quad meaning is 4. Lateral meaning is side. Any four-sided figure, what do you call? Quadrilateral. A cyclic quadrilateral is nothing but inside a circle, if you have any four-sided figure like this, it should touch all the four sides like this. This is what you call a cyclic quadrilateral. See, this is cyclic. If it is like this, do we call this cyclic quadrilateral? No, all four sides are not touching. What about this one? No, it's not a cyclic. Even if the center, if it touches like this, it's not a cyclic quadrilateral. Clear? So this is not cyclic. The first one is cyclic quadrilateral. I'll name this as A, B, C, and D. Don't write, students. When I'm teaching, listen. In a circle, when there is a quadrilateral, it touches all four sides. This is a cyclic quadrilateral. In this, there are two properties. First thing, the sum of all four sides, angle A plus angle B plus angle C plus angle D. This is second one. The first concept in the cyclic quadrilateral is opposite angles. The sum of opposite angles should be equal to 180. Not equal, equal to 180. If I take angle B, what's the opposite angle for angle B? Angle D. Both put together it should be 180 degrees, students. 180. Next, second one. Angle A is opposite to which one? Angle A is opposite to angle C. So if I add both, what should we get? 180. When you add all four, A plus B plus C plus D in a cyclic quadrilateral, 180 is 360. See, I didn't tell you it is equal, students. First, let me complete. Most of the students misunderstand this. If I write 100 here, what is the total value for B and D together? It should be 180. If it is 100, what is D value? Yes, 80D. Students misunderstand and they write 100 here. They're not equal. Their sum should be 80D, 180 degrees. So put cycle quadrilateral and take this as theorem 4 or which one? How many theorems we did? 3, right? I write it as theorem 4. That is, opposite angles of a cyclic quadrilateral, the sum of opposite angles of a cyclic quadrilateral is 180. You tell me, Bhargavi, convert this into words. B plus D. What do you mean by B plus? Plus meaning is sum, right? So convert this. Try to convert sum of. There are two angles. Are they next to each other or opposite? Yeah, converted Bhargavi. Sum of two angles. Opposite or yes, sum of opposite angles. Which topic is this? In a cyclic quadrilateral is equal to. This is what they give as theorem, student. Just convert that equation into words. Okay. In exam, they don't ask you a definition. This is mathematics, so equation is important. For reference, if you want, you'll write it. Sum of opposite angles in a cyclic quadrilateral is equal to 180. And the opposite of this is also true. If any two angles are opposite angles are equal to 180, what kind of quadrilateral is that, students? If the sum of opposite angles are equal, what kind of quadrilateral is that? That is a cyclic quadrilateral. So they call it as converse theorem or opposite. But you don't have to write all those things. Just remember, inside a circle, if opposite angles are equal, it's a cyclic quadrilateral. And the total value is 360 degrees. There's one more theorem. We'll do one more theorem. All of you completed? Cyclic quadrilateral. Okay, this was theorem 4. Theorem 5 is just the opposite, students. If you want, write it or ignore. There's no particular order. So theorem 5 is like opposite. If any two angles if the sum of any two angles, if I write it like this, if I give this 50 degree and this is 130 degree, are they on the same line or opposite, students? Look at this diagram. Opposite x, y, z. I'll write p. What is their sum? 50 plus 30. 180. If the opposite angles are equal, what kind of quadrilateral is this? It's a cyclic quadrilateral. Understood? It's a cyclic quadrilateral, but it's in a semicircle. It's on the semicircle. I'll connect it. I'll connect full like this. Look here. Do you think all four sides are touching? All four corners of this vertex are touching the circle? This is the cyclic quadrilateral. This is what they call theorem 5. It's just the opposite. If opposite angles are equal, we know it is cyclic quadrilateral. Okay. Next, last concept, last theorem is related to the cyclic quadrilateral. Last one. Exterior angle. Take down the concept. Exterior angle of a cyclic quadrilateral. Take it as theorem 5. Exterior angle of a cyclic quadrilateral is equal to interior opposite angle. See, don't write students. First let me explain. I'll give you all time. First let me explain this. Last theorem. After this we'll start solving the questions. Exterior angle of a cyclic quadrilateral is equal to interior opposite angle. So let me take a cyclic quadrilateral like this. I'll name this as A, B, C and D. What do you mean by exterior? Exterior. All these are what? Isn't it interior? These are interior, right? See, in a triangle, or if I take a triangle. Okay, give me 2 minutes. Just stay online, students. I'll be back. Okay, all of you online. Shall we continue? This part, students. Look at this. Cyclic quadrilateral. Last, it's a part of cyclic quadrilateral. If I take a triangle ABC, the angles formed inside we call interior angle. An angle formed outside, what do you call? Exterior. So the exterior angle formed is angle ACD. See, this is the exterior angle ACD. This part. In the same way, for this diagram ABCD, I'll take it as E. What are the interior angles, students? For this quadrilateral, what are interior? All of you will respond. What are the interior angle? Angle A plus angle B, angle C and angle B. And we know the theorem for a cyclic quadrilateral. Opposite angle sum should be equal to 180. Exterior angle is this red part. I'll highlight. The angle formed outside. This one. Okay. So we call this as angle. Starting point is B. Look at this. Angle B, C, E. This is the exterior angle. So according to the this one theorem, what is given, students? Exterior angle of a cyclic quadrilateral is equal to what? Is equal to interior. Interior meaning is what? Interior is inside. Interior opposite. Which is opposite to this angle B? Can you see this angle A? Opposite will be equal to angle A. So if angle A is 50 degree, BCE also will be equal to 50 degrees. This is the concept. Read the question, Bhargav. This one, Bhargav. Theorem. What does the theorem say? Read out the theorem. Quadrilateral, which is exterior angle I've written, is equal to which is interior. Interior meaning is what? Inside, which is opposite. A. For inside, see, which is interior angle? Angle C, right? Angle C is inside. You think B. B and D are next to each other, but what about A? A is opposite, right? So angle BCE will be equal to what? Angle. So today we have done 5 theorems, friend. This part I will continue tomorrow. Okay, tomorrow your class will be in afternoon for circles 10 to 11, 11 to 12, 10 to 11, 11 to 12, 12 to 1. So tomorrow your class timing is 12 o'clock, afternoon 12 to 1. All of you will make a note. Okay. See, recordings, it might be tough, students. Circle is a tough chapter. Okay, so try to attend live classes. If you have any doubts, get it clarified. Sometimes recordings you won't even have interest to complete the exercise. Okay, this part explanation I'll explain tomorrow. It's already time. I'll tell you why these two angles are equal. For now, just take these two. Now tell me the value, students. If angle A is 70 degree, what about BCE? Yes, 70 degree. I'll ask you a question. And this question is related to tomorrow's concept. Tomorrow I'll explain. I'll take angle C, students. Angle C is 100 degrees. If angle C is 100 degrees, cyclic quadrilateral, what is angle A? Use cyclic property. What is angle A? Yes, their sum should be 180, right? So if angle C is 100, angle A should be 80. If angle A is 80, what is exterior angle? This is how you get questions. They'll give you questions. So based on this, I'll tell you how these concepts are related. I'll teach you all tomorrow. Fine. So what are the concepts we studied, students? Circumference is equal to circumference. Center is equal to twice circumference. Then what are other things? Reflex angle, cyclic quadrilateral, and exterior angle of a cyclic quadrilateral. That's it for